Visual inertial sensing is a really new and exciting field in computer vision, and it's kinda hard to implement, but I hope that today, with all of what I show you, I can help you implement it yourself with the help of Pixhawk. We first need to configure the SD card we're going to put into our Pixhawk. So we actually have two directories pop up. We don't need the boot one, but we do need the other one, and we're going to etc, and then we go and find between all these folders the init.d folder. We then find the RCS folder, and now we put a very important line that makes Pixhawk start sending to ROS IMU messages at a rate of 200 Hz. This is very important because otherwise Pixhawk will send it at 50 Hz, and that's too little of a rate. We can now unmount the SD card because we made all the changes we need to do. That's pretty much it for the first part. Let's put the SD card in Pixhawk. Remember, it won't work if you won't put the SD card in. Now it's time to configure the Pixhawk from the computer with the QGC configurator. We just plug it in through a micro USB cable. After installing QGC, we go into the configurator to change some pretty important parameters for our camera triggering. First, I want to make a few mentions and say that I'm personally using the 330 configuration, since the Q330 frame has pretty similar PID values to the ones of the F330. We then go to camera, and this is very important. We make sure that our trigger is by time command and it's GPIO. We also make sure it's active low, and we just put it at 5 and 6 arc spins, and I just put it at 1 millisecond trigger signal. We have one more parameter we need to change, and that is the trigger interval. I made it 50 milliseconds for 20 frames per second, because I think that's a pretty good number. Then for the onboard mode, we go to system, and we make sure to set it up as companion link, so it would connect to our onboard PC. And also we set the local estimator configuration, so Pixhawk could use the vision estimates from our computer. We then jump into the local EKF configuration, and we have to change a few parameters. This includes the fusion of all parameters of all position data, but for our purpose we're only gonna be dealing with the vision estimate. First thing, we're gonna set the delay as 0 seconds, since our estimates are coming in real time. I'm gonna set it to 0.004, well, obvious reasons. Then I'm gonna set the covariance for the X and Y values as a bit lower than what it initially was. But I'm not going to change the Z value of the covariance because I'm a bit fond of the barometer function. We now have to change the Mavli configuration so the values will actually come at 200 Hz. To do that, we go to Mavlin main.cpp and we go to the onboard mode because we are operating our quad in onboard mode. In there, we have to change the attitude quaternion to 200.0f so it would transmit at 200 Hz the IMU values. We also changed the attitude parameter just for safety. This is very important. Now, we can change the camera parameters as well through our code in the camera trigger file. And here we have the same configuration as we had in QGC, but it is also safe to change stuff around in here, so it would stay safe. I have it written in here in the readme file. I'll upload this later to GitHub for your convenience. Again, trigger interval is the frequency of our triggering signals. The trig polarity is the polarity of our signal. The acting time is the acting time, of the signal. And the trig mode, and this is very important, is the type of mode Pixhawk should operate with respect to the triggering. That's it, pretty much. To actually enable the triggering of Pixhawk in ROS, we have to do it in the launch file. Now, I had a bit of trouble with this in the beginning, but I found that when I write one line, and that is the trigger camera, when I launch the trigger camera mav command, it starts triggering. I also modified the point gray driver so it would stamp accordingly the images according to the sync messages, and I have it here. And lastly, I have to show you the raw view file, and that is the info file. And here is the information. We have the extrinsics between the IMU and the camera calibration. This is very important, and this is, I put in the information I got for my calibration in here. It should be pretty obvious what it should be after reading some very little information. The covariance is very important if you experience drifting with your system. If you experience drifting, just up the values of the covariance and you would likely be fine. That's what happened to me. The last thing I should mention is the prediction noise. Same thing, if you see that your system is drifting, you should up these values so your system is more stable. This actually made my system stable. And lastly, there is the actual calibration of the camera, the intrinsics of the camera. Remember to put this in another file. I also want to show you my Firefly launch file for my point gray camera just for reference. In here I added a in sync parameter to say whether the camera is in sync with the trigger signal or not. We're gonna set it to true. And I have a lot of other parameters which are important. These I will also upload to GitHub for your reference. Let's make a little test for our camera. We first launch up our camera node and then we reconfigure it. I want to show you this in order to prove to you that there is actually triggering. So right now we're seeing the camera and here is my hand, right? And here in the dynamic reconfigure, I have this parameter called mode. The mode is set to mode 1, and this is very important because if I set it to mode 0, as you can see, the camera stopped triggering. This is kind of complex to explain, so I'm not really gonna go into it, but basically it's because Pixhawk needs to get information back, but you know. Anyways, I just launched the Pixhawk node, and I'm gonna now change it back to mode 1, you know, so it works again. And now when you see the topic of Mavros of the cam IMU sync, you will see that it is coming at 20 Hertz. There you go. Now we can do the same thing but with the image raw topic, and you will now see that it is also coming in at 20 Hertz. So it's working pretty well. It's time to bring out the big guns. And right now I'm gonna launch my ROVIO node. Now I actually hard-coded the topic names into the code for convenience. But as you can see, it's working. If for some reason you see the features just drifting around, then you will see that it's not working. And now I'm gonna echo the odometry topic. And as you can see, it is staying at 0, 0. This is a good thing. This is a very good thing. It's working. I'm gonna move it around a bit, and you see that there is a slight drift, but overall the position is not drifting at all. So Rovio is indeed working. We are now done. I'm gonna unplug my Intel NUC. It's enough for today, and we'll let the drone, well, just sleep, I guess. Until the next time, fly safe.